soldering. So we'll probably work on that the last 2 classes. So we're going to look at measuring devices. So these kits come with a scale ball strainer, and it's basically everything that you need to take it apart. And then plus it's got all the measurements that you would have to make sure you assemble it back right. So I added some more. So measurement, instruments, and tools, right? Okay. So first of all, we'll learn about what's an accurate measurement, review the different types of measuring instruments and their applications, learn how to calibrate the instruments, and care and maintenance, and of course, we're not going to do advanced diagnostics. So what does it mean? What's instrument? What is that? How would you define an instrument? I need to put that in our dictionary. Well, that would be a machine. That's basically what we use machines for, to measure. Instruments are measuring devices, so they're used to measure different things. So you run into instruments when you go in the doctor's office. You run over instruments all over the place. But basically, instruments are what we use to measure, right? A measuring device used to gauge the level, position, speed, etc. of something, especially motor vehicles or aircraft. But we use gauges. These are instruments, right? You understand that? So these are our measuring devices. So what do we do? What devices will we look that we measure with? That y'all measured with? Yeah. Calipers, micrometers, tape measures, rulers, which tape measures and rulers are basically the same. Air gauge, right? Okay. Tire gauge. What is accuracy? Tire tape? What's a tire tape? Oh, okay. Round tire. I didn't know that's I always called it a tape. There you go. Free of any errors, especially as a result of care, right? Able to give an accurate result. So this is accuracy. And this is what this slide, this is not my slides, by the way, but the guy didn't put his name on it. He did. I wish he did, because it's pretty good pair of slides. But this guy must have been a mechanic. And so what he talks about failed measurements. We had a lawnmower, a Cub Cadet riding lawnmower that we used to rebuild, and we'd do everything. And what happened is we decided to rebuild it, but the people who was maintaining it before for our neighborhood, it was our neighborhood mower, the engine messed up on it, and they took it off and had it rebuilt. And what they did is they put different heads on it. Of course, the heads wasn't quite as long, so they came in and replaced all the valves, everything that did that. But when we went out there, and one of the what do they call the push rods on the bottom that run, that's what they call it, that pushes up the piston. Yeah, it broke. So we went and we ordered it, and the guy looked our motor up. He looked up the motor on there, and gave us the rod. We went back, put it on, and as soon as we started cranking it, you could hear the piston. You could hear the piston hitting up against the stop because of what? Bad measurements. So when we took it out. The guy come out of the shop. He was really guys. I forgot his name. He was down here on the Highway 150. He came out and noticed a number on the side, and he said it was a different block that they had put on there. So they didn't put the right block on there, so we were using the wrong measurement. Luckily, we caught it right off the bat, and there was really no damage to it. but we had to go out and he had to give us the right push rod for that block. So this is kind of stuff that could be called. So this is what we could happen right here. So just having the wrong measurements, not putting in something there right. It's stupid, right? This is not mine, guys. So this wasn't in the top. So this guy didn't cover rollers. So we have rollers, we have metal rollers, we have machinist rollers. And so we got this inside our box. So what's the difference between a metal roller and a machinist roller?
Metal roller is longer, machinist roller short.
So this is our metal roller. It's in the top. So if you look in the top, it's in a little slot right here. This is a metal roller. This has inches on one side, and it's got centimeters and millimeters on the other. Oh, I'm sorry, I got it froze. It is recording. I was looking at the grade book a while ago. Is it up there now? So centimeters. So this would be centimeters here, right? Where am I at? Way down here, guys. So this would be centimeters. So each one of these small little slashes, there's 10 of them. So those would be what? Millimeters. Yeah. So this is pretty standard for most metric. So the best we could do on this would be millimeters. That would be how accurate it would be. This is the machinist tool. The other rhythm. I must have got it out. Now this one, you can get it in inches also, but this is in millimeters. So this would be 10 millimeters, right? Which would be 1 centimeter, right? You understand? Is that okay? And then this would be half millimeters down there. This is more accurate. But what makes it the machinist tool is if you take so what they do on this one, because they know these guys get used a lot in gloves and stuff like that. So to prevent the numbers from getting more off, all these are actually, can y'all run them across that? You can feel it. They're etched in gray to keep them from doing what? Wearing off, yeah. So that's the difference between this. So these basically here, and I've got rollers over there now that the numbers are actually wore off just from doing what? Handling. So that's one of the things that they talk about a machinist roller is that all the numbers and everything are engraved on there. So it means these right here won't wear out. Of course, we use these to measure, and we also use these a lot as a straight edge, right? So these things are very accurate as a straight edge. So a lot of times when we're adjusting pulleys and stuff like that, or we can lay a straight edge across that to make sure the pulleys and also the gears are the sprockets are lined up correctly. And then of course, we have tape measures, Rich. So tape measure is also in here. So it's toward the front. So most of us hopefully has used one of these things. Everybody use tape measure before? Yeah, but a flexible roller, yeah. Now these are not, we got carpenter's rollers. Y'all seen those? They basically fold out and they're big and then they fold out and they're usually made out of wood. And then we got wood rollers and then of course plastic rollers. So this one here that they've got in here, this has got centimeters, it's got millimeters, and then on one side it's got inches. This is usually the one we're going to, and guys, you're going to have to get used to it. You're going to have to get used to the metric system, right? You understand? So slowly and slowly, especially in our neighborhood, where we're getting a lot of companies that come from over where that metric is the thing that goes, right? And of course, metric to me makes a lot more sense because everything runs in tens, right? So we got, how many inches in a foot? 12. Where'd they come up with? How many feet? How many inches in a yard? 36, right? How many feet in a mile? 5,760. Where'd they come up with that stuff, right? But in the metric system, everything moves in what? Tenths. Yeah, which is even in temperature. How did they come up with 32 degrees freezing and 212 degrees boiling?
No, foot, I was doing like king's foot.
Yeah, that's what I learned. It some king and an inch was the space between the tip of his fingers and his first joint and stuff like that. That's what I learned. The way they came up with those measurements.
Egyptians used something else.
They use cubics.
Like on the tip of the finger to
Yeah, we used to say a yard was from the tip of your nose to the tip of your fingers. That's why they came up with the yard. But I don't know how they came up with it, with an inch. Why they called it an inch? So then we're going to look at micrometers. We're going to look at calipers, vernier calipers, dial indicators. We don't have any telescopic gauges or small gauges or thickness gauges, but we've got the equipment that gives us the ability to do this. So the first one we look at, so you can pull this out. This is called a micrometer. And this one is fixed. So this is in millimeters, and it'll measure from 0.1 millimeter, which would be how many microns? 0.01 millimeter. How many microns? That'd be 10, right? So 0.1 millimeter would be 100 micrometers, but most people call it micron. So let's see if y'all can, let's look at the parts. Let's see if they tell us the actual parts. Do they? Everybody got one they can see? So this is, we use this to measure outside, right? We use these to measure thicknesses. Everybody okay? So y'all can pick this up and make sure you just don't drop it. We never ever want to drop precision tools, right? Everybody okay? I'm going to try to find a slide that shows us the parts. It'll be there. So here's parts. So y'all can see also on the very back we have the little ratchet cap. See the little ratchet cap on the back, on the very end. And then we have what we call the what? Thimble. And then we have a locking mechanism so we can go in and make a measurement and we can lock it down so we don't accidentally turn it when we're bringing it back up. And then we have what they call the measuring rod. Now we got some over there, I'll go get them, where we actually can replace the rod. So the one we have is a Craftsman. And you can go from like a 1 inch all the way up to 6 inch, I think, by changing out the rod, changing out this rod right here. Now what we do, guys, is we put what we want to measure the thickness in between the rods, right? You understand that? And then we start turning the thimble until it gets close. And then we move to the little ratchet and we turn it until it clicks once. Okay. So y'all can just put that in, it don't hurt. So let's just put it like in our finger or something like that. And let's let y'all do that. So this is for coarse adjustment. Oops, I'm gonna find it. This is for coarse adjustment. That. And then what you want to measure, I don't think it, let's see if it'll measure this level. No, let's do this. I move it this way. It's going to be close. No, it's not going to do it. I'm going to measure. So, of course, you measure. So what we do is we take this and we turn it until it what's? Not here. We turn this until we get close, right? The thimble. We turn the thimble until it gets close, right? And then when we get close, what do? We stop and start turning the ratchet, and we want to turn it till it what? Clicks once, right? Raise this thing up so I'll get up. And then when it clicks once, then we've made our measurement, right? Everybody understand? That makes sense? Are we okay? Okay. Now this is the locking mechanism right here. So you notice when you come over here, you push that up, and then of course then you can't turn the thimble anymore. And the ratchet don't mean anything anyway, right? You understand that? Everybody okay? Yes or no? So how are we going to read this thing? Let's look at the scale on this one. First of all, we'll check to see if it's zeroed. So we turn it down, get it close, and then I'll come up here and turn it. So this is off just a hair. So we'll have to show you how to calibrate that. So when I got it on zero, the zero line on the thimble should line up with the zero mark, should line up with the mark on the that the thimble goes into, right? That's what I'm talking about? Yes or no? Okay. So the way we read this, each one of these would be a millimeter. So I just went 1 millimeter. I just opened it up 1 millimeter, right? Understand that? So every time zero comes around, and what we do is we look at the major line. Oh, I'm sorry. That is not 1 millimeter. This is 1 millimeter. Now the way this mic is set up, this is a little different from the inch. See if I can zoom this in. Are y'all listening? Okay. So we got a mark up here, and then we got a mark down here. You see what I'm talking about? Yes or no? Yeah. Okay. And when we look at this, it's laid out in, this is laid out in 50s, right? You understand? That makes sense? So I come up here and line it up, and I start opening it up. Then it went around once to zero, but it's lined up with the minor division, so that's going to be what? Okay, so what we're doing, okay, I'm sorry. Okay, so it's lined up on zero, right? And I start opening it up. And I go around, oh, sorry, went past it. Okay, so that's zero right there. What would that be? Yeah, but I'm zero on the first one. So this is zero. So what we're doing is we're looking at, yeah. So we're looking at this line right here. So now it's lined up on zero. I know it's hard to see that. Y'all might have to come up here. It's the first one on the bottom. So if I call this the top on the same side as it's got the numbers, Okay, notice it's in 50s, right? See that? Now when I turn it around to the first 50, that's going to be what? So then I turn it around again to the second 50.
100,000.
And it comes up to the second line, right? You understand? So this right here is a millimeter. Are we okay? Well, if this is a millimeter, I'm sorry if so to get a millimeter, I have to go around what? Are you leaving, Trey? I mean, you already know how to do this? So if I come over here and this is 0, right? Y'all understand? Then this right here, when I go around once back to 0, it's lined up on the second, the bottom. They'll come up here. Forwardly. So this comes in 2 parts. So we have the stand for it. And then we have the dial indicator. The stand is a magnet. And you can turn the magnet off and on. Basically, it just pulls the magnet up. So when you turn the magnet on, then if you got a piece of metal, it'll actually stick to it. And then we have all these mounts and this neat stuff right here. So what are we going to use these guys for? Anybody ever use one of these? Okay. So what do we normally use these for?
Very small, very small increments.
Well, we can use them to measure the roundness of something, right? So what we can do is make sure a shaft is not wobbling on us. So what we can do is we can set the dial on one part of the shaft. We can zero it out. It zeroes out basically the same way that the caliper zeroed out. So we got this little clamp right here that we can loosen up. So what we can do is we can put this on a shaft or something, mount it real solid, right? You understand? Put it on a shaft, set 0, and then rotate the shaft. If we ever see any wobble on that, we know that the shaft is not aligned correctly. If a shaft is not aligned correctly, it's going to give us all types of problems with our wand, with our bearings and everything, right? So we can use it for that. We can check different parts to see if they're the same height, right? You understand, real fast. We could do that, but what we have to do on this one is we have to make sure that this base is at a good reference point, right? You understand? So I can't move the base around once I've established what a 0 is. So this guy here is about the same. It says our dial is set up in 0.01 millimeters. So what we can do is we can swing it around, we can move it in and out. And then this guy right here would set the actual angle. So you can see with, can y'all see what I'm adjusting? Yeah, this right here, you can actually change the angle, right? See what I'm talking about? Okay, so what I've done is I've got a 0 set on it. And how do we set the 0? We break it loose right here, right? And then we can turn the whole face. Everybody okay? Okay. Huh? Yeah, it's got the hand up here, right? Okay. So this right here would be 1 revolution. That would be 2. Y'all see what he's talking about? So it's picking up, guys. So what would you measure? Oh, sorry. Can y'all see it? So this guy's sitting on 5. This guy right here is sitting on 6.
Millimeters, right? So 6.95.
Y'all see what he's saying? Can y'all see it?
6.94.
Yeah, it's a piece of plastic. It's going to move. Yeah, that's 2. That would be 92, right? 92, right? Yeah, there's 10, right? So that's 0.01. Y'all see that? That makes sense? Everybody okay? I see machinists use this a lot just to check, make sure the part is flat. So they'll move the part under there and see if it moves up and down. Checking to see if their milling is done correctly. I'm sorry, this guy, let me move it back a little bit and see if it'll focus. It almost focused. So I got a different measurement. This is made out of plastic. This is made out of. Oh, there we go. So now it's measuring a little bit different, but notice it's less than 6, less than 7, right? You understand that? And each one of these minor divisions would be worth a what? So it'd be 6.98 millimeters. See that? Yes? No? That makes sense. We have focused them real good. So first thing we do is look at our major divisions right here. Then we drop back and look at our what? Minor divisions. Everybody okay? That makes sense? We'll get different measurements. We have depth gauges. We have all these different things. Just about these 3 tools, though, you can make just about any measurement you need to make. So the rest of the PowerPoint shows you how to read it, right? Which we've already looked at. Set up. Forward. This is don't see the one that we got. Inside mic, but we can use our caliper for that, right? Depth micrometer, we can use the mic for that. Digital is really nice. This is what everything's going to. But what I say, if you learn how to read the mechanical ones, then you understand the digital ones a lot better, right? So don't what?
Don't drop.
Don't run over. Right? Don't over tighten them. Right. Don't leave covered up. Take care of it. Don't let somebody borrow them, right? Don't leave laying around, right? Right. And then fuss at them when they do that. So I'd be the same as somebody tossing an open knife to you, right? Here, can I borrow your knife? Yeah. Keep locked up. Keep away from everybody. Keep in practice reading, right? These are pretty good rules. Okay, guys, what we'll do when we, I think our test is, when's our test?
Next week.
And we've got, we're doing okay. So let's look at our calendar. So right now, we got one more thing we'll look at, and we'll finish the theory up at the first of Monday's class, and then Monday and Wednesday we'll work with putting the robots together and soldering them. So what we're going to do is and this is a pretty neat kit. So this is what we're going to put together. It's called an avoidance robot. And what's nice about it, it works. We got a gearbox we put together, right? You see gearboxes. We'll get to play around with soldering. This guy runs off a microcontroller, so we'll let y'all play around with soldering a little bit. This is a diffuse sensor, but it works in conjunction with these guys right here. So what does the diffuse sensor do? How does the diffuse sensor work? Yeah, but it works off reflected light. So what this thing does is these guys right here, these are infrared light emitting diodes. And what it does is the way the program does is it pulses one of these at a time. And if it sees reflective light, so if it sees this one reflect, then the controller will turn it that way. If it sees this reflect, then the controller will turn it this way. If it sees this reflect, it'll turn basically all the way around. So these are avoidance robots. It works off a little microcontroller up under the battery pack. By the way, guys, if you're not going to use something for a while, then what do you need to do with the batteries? You need to take them out, because somebody left batteries in this, and eventually alkaline batteries and carbon batteries will just eat themselves up because they got acid in them, right? Understand that? So they'll eat themselves up, and then all that goop runs out, and it gets on your connectors, and it eats the tin coatings off of them, and then they'll rust real fast. So anytime you got something that you're not going to use for a while, what you need to do is take those batteries out, right? Understand that? So this is what we're going to be putting together. And what we'll do is we'll split it up. Some of y'all will be mounting and soldering, and some of y'all will be building the gearbox, and then we'll swap up and make sure everybody gets a chance to solder, and also everybody gets a chance to work with the gears. So we talk about soldering on Monday. So let me log in and look at the calendar. I don't think we got much of an option with this class. So I think test is Yes, need to store everything, put it back where we got it from. But let's go back over the calendar first. Make sure we know what's going on the rest of the term. So we got a test coming up. What's due before the test? The previous test, right? Previous test 2 is due before the test. No, 2, because before test 3. They're on the table over there. Those 2 tables.
All 3 of them?
Just 2 of them. 2 of them stay over there. But it's okay. What we've done is we've added it to our end of course evaluation, so you don't have to follow those things, right? So you click on this. In fact, it's a little better because the way I've got mine set up, it takes you directly to the login screen. If you use that on their email, it's going to take you to a link to a link to a link, right? So this is the way you log in, student ID and your birthday, you're okay? I'll get up to it in a minute, guys. I can tell y'all ready to go. So tomorrow, if you want to drop a class, it's not only this class. If you need to drop a class because you're not going to pass it, tomorrow is the last day. If you wait to then, you get a grade. If you drop it here, you get a W. Y'all know the difference, right? And then we have an assignment due here. In fact, we got 2 assignments to do. I need to go back and tell that. So, assignment due, this is PT2, but also what's due before test 3? Course evaluation, right. And then it looks like we got an assignment 5. What is assignment 5? No, that's the last assignment. Assignments, course survey, I put it as the last assignment, and that way I can copy and paste it. So assignment 5 is, well then, no, next Friday. Assignment 5?
You said that thing out talking about you all.
No, this is safety rules.
You filed assignments before midnight. You said do them by midnight.
No, that was assignment 4 because some of y'all hadn't done it. So
It was 1 through 4.
1 through 4.
Yes, sir.
Assignment 5 is a